Hello, this is Mr. Westwater here, and today I'm going to take you through the Year 10 paper from June. Okay, so we start that with question 1, and here we have some fractions and we're being asked to order them in terms of size. Now we can do various things to sort of go through this. We can try and convert them into the same sort of fraction. We can change them into decimals. I'll go through both methods and then you can decide which one you prefer. Okay, now the easiest one possibly is to turn them into fractions, maybe out of 60. So this would be 10 out of 60, multiplying top and bottom by 10. This would be 6 out of 60. 3/4 is going to be 45 out of 60. Timesing top and bottom by 15, and a half will be 30 out of 60. Okay, so our smallest one is saying start with the smallest fraction, is going to be 6 out of 60, isn't it, which is 1/10. So actually let's not write it as the changed form, so 1/10 is the smallest fraction. Then we have 1/6. Then we have 1/2, 30 out of 60, and then we've got 3/4. Okay, so those are the orders. Alternatively, if you type these fractions in on your calculator, you can see that 0.5 is a half, 0.75 is 3/4, 0.1 is a tenth, and a sixth, I will have to use my calculator for this one, comes out to be 0.16 recurring. Okay, so again you can see from this that 1/10 is the smallest, then it will be 1/6, then a half, and then 3/4. Okay. Write a quarter as a decimal, this will be 0.25. Okay, 1 divided by 4. Again, you can use your calculator and then use the SD button to change it into a decimal. Write a fifth as a percentage. Now a fifth is 0.2 as decimal, which if we times by 100 is going to be not 2 but 20%. Okay. Alternatively, we can turn this fraction into something out of 100. So if I times top and bottom by 20, I would get 20 out of 100, which is 20%. And I've got the percent sign there, so I don't need to add it in. And work out 1 minus 5/8. Well, 1 is 8/8. Okay, so if I take away 5/8, I'll be left with 3/8. Ooh, whoops, 3/8. There we are. So there's question 1. Okay, factorise 3x squared minus x. Now, this is a quadratic, but we wouldn't actually need to put this into 2 brackets at all. The first thing we should be looking at is, are there any common factors? We have an x in this term and an x in this term. Now there are no numbers which go into both, so I can only take out x as my common factor here. And then I ask myself, well, what do I need to multiply x by to get 3x squared? And the answer is 3x. And what do I need to multiply x by to get this minus x? I need to multiply it by minus 1. So this is going to be my answer. X, 3x minus 1. And expand 4 brackets 2y plus 3. So it's important we multiply this 4 by the 2y first. So that's going to be 8y. And then we multiply the 4 by the 3, which is 12. Okay. So my answer is 8y plus 12. Okay, and part C, we want to work out the value of C when A is minus 3 and D is 6. So capital C is going to be 5 times, and if I use brackets here, minus 3, add 4, and then brackets again, times 6. Now you can either type this in on your calculator or you can work it out manually. 5 times minus 3 is minus 15. And 4 times 6 is 24. Either way, if you do this, we should end up with 9. Okay, so C is 9. Just checking it on my calculator, and it seems to be fine. complete the table for values of y equals 2x minus 5. So again, if you know how to use your calculator, you can go into your table mode on your calculator and enter, I think it comes out as f of x, and what you need to enter is this 2x minus 5, and we want to go up in steps of 1, because it's jumping up by 1 each time, and we want to start at minus 2 and we want to end at 4. So that's if you use the table function on your calculator, and that will be able to just read off all of these values, and you can check it's right by looking at the minus 1 value, the minus 1 value, the 2 value and the 3 value, and check that they're minus 7, minus 1 or 1. Or alternatively, you can just go term by term and substituting these values in on your calculator, or doing it manually. So you can say 2 times minus 2 minus 5 is going to be the answer for this one, and this is minus 4 minus 5, which comes to be minus 9. If I carry on through this, this will be minus 5, minus 3, and 3. Okay. So lots of ways you can go about doing that one. And then on the grid, draw the graph of y equals 2x minus 5 for the values of x from minus 2 to 4. Okay, so when x is minus 2, y is minus 9. So let's enter that coordinate first. So remember, x is across and y is the vertical axis. Okay, so minus 2 is minus 9, minus 1 gives me a value of minus 7. If I keep plotting these, okay, it will look something like this. Okay, now you may notice that this would normally have a gradient of 2, so for every 1 you go across you go 2 up, but because they've changed the axes, so this is 1 unit, but over on our horizontal axes 1 unit is covered by 2 squares. It doesn't just go 1 across and 2 up, because it will go 1 unit across and 2 up, which is actually 2 squares across for every 2 squares up. So our straight line is going to be something like this. Okay. Okay, question 4. In fact, is that everything? Yep. Okay, so question 4. We are trying to show that 1 2/3 plus 2 3/4 equals 4 5/12. Now, the way I like to do this is to change, well, let me start again. So the way we go about doing this is we ignore the right-hand side for now. That is our answer. So we don't want to use that to help us solve it. We can sort of refer to that at the end and check that we've got the right answer. But what this question is asking us to do is this calculation on the left. Okay. Now, because we can use a calculator to work it out, this has to be a show that question, because otherwise it would be too easy, because you could just type these numbers in on your calculator. So first things first, we need to make it a top heavy, or an improper fraction. Okay, so 1 2/3, if I times 3 by 1 and then add the 2, okay, this will give me 5. So 1 2/3 becomes 5/3. Similarly, 2 times 4 and then is 8, and then add 3 is 11. So this will give me 11 over 4. And now they are top heavy. But in order to add these, they need to have a common denominator. So our common denominator here between 3 and 4 is going to be 12. So I'm going to multiply this left fraction top and bottom by 4, and multiply this right fraction top and bottom by 3. So 5 times 4 is 20, and 3 times 4 is 12, and 11 times 3 is 33, and 4 times 3 is 12. So now they have the same denominator, I can add them all together. So remember, the denominator will stay the same, whereas the numerator will change. So 20 add 33 is going to be 53 over 12. Okay, And now if we think about this a little much, we've got 12, 24, 36, 48, and then I've got a remainder of 5, haven't I, before I get to 53, if I use my 12 times table. So that will mean this equals 4 and 5 still to be divided by 12. So I have shown that by going from my left-hand side, I have now got my right-hand side, 4 and 5/12. Okay, here are the first 5 terms of a number sequence S, and we are trying to work out an nth term for this sequence. So we need to think, what times table does this relate to? So what are the jumps each time? Well, each step we are adding 6, so this is similar to the 6 times table. Okay, so this is going to be similar to 6n. Now 6n would give me the sequence of 6, 12, 18, 24, and then 30. So how do I get from the 6n sequence to this new sequence? Well, I have to add 4 each time. Okay, so this sequence must be 6n add 4. Another way of working out this number at the start, it's the 0th term. So what would be the term before 10? Well, it would be 4. So that's another way of working out that value that you put after the 6n. The most common mistake here is people thinking we go up in 6s, so we plus 6 at the end. But remember, the jump each time refers to the times table. So we are looking at 6 times whatever term it is. Okay. On Saturday, Jacob walked 10,800 steps. On Sunday, he walked 7% more steps than on Saturday. Work out how many steps Jacob walked on Sunday. So I like to use the formula our starting value times our percentage multiplier equals our final value. Okay, so what is our starting value here? It's 10,800, and if we are increasing by 7%, well, we start at 100%, and then if I add 7, I now have 107%, and as a decimal, this will be 1.07. So I need to times by 1.07, and that should give me my final answer. So let's enter that into my calculator, and I get 11556. Okay, it's in context, so maybe I should put steps afterwards. Just work out how many steps Jacob walked on Sunday. Yeah, I'm happy with that. Okay, we have a right angle triangle. Now, whenever I see a right angle triangle, I think of 2 things. I think of Pythagoras, and I think of trigonometry. Now, trigonometry must have an angle, and this question doesn't seem to have an angle, so I'm going to guess that in this question we're going to use Pythagoras. Let's see. So we are being asked to work out the length of PQ. Now, I know that this is also a right angle because it's on a straight line, and to be able to work out PQ, I can use Pythagoras' theorem with this length of 5, but I also need this vertical length, and I don't know what that is yet. But what I can do is I can use this triangle on the right with Pythagoras to work out this vertical height. So I like to use the formula a squared plus b squared equals h squared, because h reminds me that it has to be the hypotenuse, which is always opposite my right angle within the triangle. So this is going to be 14 squared. Okay, now A and B, it doesn't really matter, but for the sake of argument, we'll call this A and we'll call this B. Okay, so we can say 10 squared add B squared equals 14 squared, and I can work out these values now. Okay, whoops. So this is going to be 100 add B squared equals 196 if I type this in on my calculator, and then if I take away 100 from both sides, then I end up with B squared on the left equals 96. Okay, and so B is going to equal the square root of 96, which comes out as where are we? 9.79795, and it carries on going forever. Okay, but that's not what we're after. We are now going to use this to work out this hypotenuse. Okay. Okay, so what I could do is I could store this in my calculator by pressing Shift STO at the bottom, just above the 7 button, and then picking a letter. So I'm going to store this under A for now. If you're not sure how to store numbers on your calculator, do ask me and I'll show you how. So to work out H on PQ side, I know that I can use, again, A squared plus B squared equals H squared. This time I'm working out H squared. And A in our case this time is going to be 5 squared, and B is going to be this 9.9795. What I'm actually going to do is actually write it as a square root. I'm going to say root 96 squared. Okay, and this means that when I square the square root, it's just going to undo it. So it will just be 96 equals H squared. And 5 squared equals 25, so overall H squared is going to be 25 add 96, which is 121. Okay, and if I square root both sides now, we get H is exactly 11 centimeters. Okay, so I'm just square rooting both sides there. That was a tricky one though. Okay, question 8, sets and Venn diagrams. Okay, so the first question is asking me to list the numbers that are in the set A. Now this doesn't just mean these values here. It means anything that's in the circle A. So it's also going to include these numbers in the middle. Okay, so let's list them. So we've got 2, 4, and 6. We've also got 8, 10, and 12. Okay, and list the numbers that are in the set A and then this funny N symbol B. Now I always remember this N as meaning and, so it has to be in both A and B. It's our intersection. Okay, so that's just going to be 8, 10, and 12. Okay, and list the numbers that are in the set A, U, B, and then this little apostrophe. Now, this apostrophe in mathematical words means complement, which if you want that translated means not. Okay, so we are looking for things that are in A, and now this symbol means union. Okay, so we are looking for things that are in A or B. So that's everything that's either in A or B. So it's actually all of this. Okay, but our question is saying I don't want those. So what's not in A or B? So what's not in here? Well, it's just these three down here. 1, 3, and 5. Okay, so 1, 3, and 5 are going to go here. And one of the numbers in the Venn diagram is chosen at random. Find the probability that this number is in the set A union B. So we have 12 numbers altogether. Ooh, whoops. And we're looking at the probability that it's one of these 9 numbers in A union B. So that's 9 out of 12. Okay, so we've got 9 out of 12. Now really I should simplify this, and this does simplify nicely down to 3/4. Okay, so we've got 9 possibilities out of 12 in total. There are 12 numbers in total in this Venn diagram. Question 9. The length of a line is 12.3 centimetres correct to 1 decimal place. So if I think about this on a number line, okay, and I've got 12.3 here, and I guess 12.4 and 12.2. This has been rounded to 12.3 to the nearest 1 dp, and these are all to 1 dp on my number line. So it's got to be anywhere above this point, or it's going to be somewhere in that sort of range. Now this value at the top here is going to be 12.35, and this value below it is going to be 12.25. And we call this lower value our lower bound, and our upper bound is this upper line. So our upper bound is 12.35, and our lower bound is 12.25. Okay? The key thing is the fact that it says at the start of the question that we have rounded. Okay, and this indicates that I need to be looking at upper and lower bounds. Okay. Question 10. Omar invests 6,000 dirham for 4 years in a savings account. He will get 1.5% per year compound interest. Work out the total amount of interest Omar will have received by the end of 4 years. Give your answer correct to the nearest dirham. Now so that's 1 unit is a dirham, I'm guessing. So if I'm increasing by 1.5%, again I can think that I start with 100 and I add 1.5. This is going to give me 101.5, which as a decimal multiplier, remember, we are going to be timesing by 1.015 each year. So after 1 year, so let's call this year 1, we will have 6,000 times 1.05, 1.015 I should say, and that's 6,090. Now in year 2, we're not going to use 6,000 again, or we're not just going to add 90 again. We need to take our new value, which is 6,090, and times this by 1.015. Because 1.5% of this new larger amount is going to be more than 1.5% of our smaller 6,000. Okay, I'm going to change 6,000 to 6,090, and I now get 6,181.35. Okay, so that's at the end of year 2. Okay, we need to work out what it's going to be after 4 years. Okay, so I can do it again. In fact, what I'm going to do on my calculator, I'm going to replace 6,090, and this time, instead of writing out 6,181, I'm just going to use the answer button. Okay, so that will take my previous answer and times it by 1.015, and then the next value is going to be 6274.07025. If I press it one more time, we get 6368.18130. It probably carries on going, but remember our question asked us to the nearest dirham, so that will just be, if I round it, it will be from here, and I look at the number to the right. Now that's a number between 0 and 4, so this is not going to be rounded up, it's going to stay as an 8. So my answer is 6368 to nearest dirham. So let's write that down, 6368. So this is, I think, the most hands-on approach. There is an easier way of doing this, because each time we are multiplying our answer by 1.015. So what we could have done if we were clever about this, and I'm just going to draw a line under this, is say, well, I've got 6,000, and I'm going to times it by 1.015, and then just times that by 1.015, and again times it by why have I done 101.5? Right, 1.015 and 1.015, or actually, better still, as I've got 1.015 timesing itself 4 times, I could write this as 6,000 times 1.015 to the power of 4, and that will give you exactly the same answer. Okay, so let's type that in on our calculators. 6,000 times 1.015 to the power of 4, and yet it gives me exactly the same answer. Okay, so let's just check the question briefly. So it says work out the total amount of interest Omar will have received. So actually this isn't quite the right answer. So this is how much he has, but he invested 6,000. So the interest is just going to be the amount he's gained from that 6,000. So if we do 6368, which is his amount to the nearest dirham, minus 6,000, that will give us his actual investment, which is 368 dirham. Okay. Okay, question 11. So we have the diagram shows 2 water towers in Kuwait. The real height of tower A is 187 and the real height of tower B is 147 meters. Ahmed makes a scale model of both towers. The height of tower A on the scale model is 90 centimeters. Work out the height of tower B on the scale model. Give your answer correct to the nearest centimetre. So what we need to do is work out how we've gone from 187 metres to 90 centimetres. Now the first thing we need to be careful of is to make sure they're the same units. So remember, there's 100 centimetres in a metre, so this is actually 187 and then 2 zeros centimetre. So what's the scale factor here? Well, our scale factor is going to be our 18700 divided by 90. Okay, so let's type that in, 18700 over 90. It's not a very nice number. It comes out at 207.7 recurring, or if you want to write it as an exact value, as a fraction, your calculator will give you this as 1870 over 9. We need to use that scale factor to go from our value of B to a centimetre. So if I do 14700 divided by this 207, in fact what I'm going to do is I'm going to use the answer button to make sure it's exact. So 14700 divided by my answer, and I get 70.74866. In fact, it goes on for quite a long time. And again, this is asking to the nearest centimetre. So I draw an invisible line down here and say, well, will this 0 be rounded up or will it stay the same? Well, the next number is a 7, so yes, it will be rounded up. So it's going to be 71 centimetres to nearest centimetre. Okay. And let's just make sure that this makes sense. Now the taller one got made into 90 centimetres, and so this slightly smaller one being made into 71 does make sense, so I'm quite happy with that. Okay, now our last question, I think. Yep, last question. So, solve the simultaneous equations, 4x plus 2y equals 9, and x minus 4y equals 9. So I'm going to do this in two different ways. Okay. Both are fine, but the key thing is we want to make our coefficients the same amount, so the same number of x's or the same number of y's. Okay. So I'm going to start off by making the same number of x's. So I would need to multiply this second equation by 4 so that we have 4x's in both equations. This will mean I have 4x plus 2y equals 9 in my first equation. It would stay the same. In my second equation, I'm multiplying by 4. So x becomes 4x. 4y will become 16y, and this is minus. And 9 becomes 36. Now, as they're the same sign, they're both positive, to eliminate the x's, I would need to subtract one equation from the other. Now, this can be a bit tricky. 4x minus 4x will be 0x, but 2y minus 16y is going to become 2y plus 16y, which is actually plus 18y. One of the most common mistakes in this question will be people taking away 16y and being left with something like minus 14y. And then 9 minus 36 is going to be minus 27. Okay, minus 27. So I've got 18y equals minus 27. And so y is going to be minus 27 divided by 18. And if I simplify this, if I type that in on my calculator, minus 27 divided by 18 is minus 3 over 2, or minus 1.5 if you want to write it as a decimal. Now this is not the end of the question. I now need to use this value to work out x. So I'm going to substitute my value of y into one of these equations. Now which one should I sub it into? It doesn't matter, but let's sub it into our second one. Okay, so x minus 4 times minus 1.5 equals 9. So let's work this out. This will become minus 4 times minus 1.5 is actually plus 6. Okay, so x plus 6 equals 9, so x equals 3. Okay, so those are my answers. X equals 3 and y is minus 1.5. Now before I lock these in, I'm just going to check that these both work in our other equation. So if x is 3, this will be 12. And if y is minus 1.5, 2 times 1.5 is 3. So this is going to be minus 3. And that does equal 9, so I'm happy with that. So I'm going to lock in my answers of 3 and minus 1.5. Now I did say there was another way of doing this. If you wanted to, you could have made the y's the same, and that in that case you would have been timesing the first equation by 2 and leaving the second equation as it was. Now I'm going to run through this one quite quickly. So our first equation would be 8x plus 4y equals 18, and our second equation would stay like this. And this time, because for the variable, the y has different signs in front of the same number, we'd need to add them to eliminate the y's. So if I add these, I'll get 9x plus 0y equals 27. So 9x equals 27, and dividing both sides by 9, x equals 3, which is what we found before. And again, I can sub this value of x into one of the equations. Let's sub it into the first one the second one this time, okay? So 3 minus 4y equals 9. So taking away 3 from both sides, we would have minus 4y equals 6. And then dividing both sides by minus 4, 6 over minus 4, which again equals minus 1.5. And again, you can check it in the top equation. Those values of x and y work. Okay, so there you have it. 40 marks for your paper. Okay.